Wouldn't it be really cool if we could collect energy from space and bring it down to our planet? That means we wouldn't need to get electricity from wind, water, or other resources available on Earth. Millions of people would charge their phones, store food in the fridge, watch TV, and do so much more thanks to electricity we'd get wirelessly from space. It kinda sounds too good to be true at first, but this idea isn't science fiction anymore. Not only is it possible, but we might see it sooner than we think, maybe even by 2040. SEI is short for Space Energy Initiative. They're currently working on an exciting project called Cassiopeia, and its main goal is to place a constellation of big satellites in a high orbit of our planet. Once the satellites are in their spots, we're likely to get access to big supplies of solar energy. Almost unlimited, some would say. We can get 40 times more energy from solar panels in space than from those located on Earth. Space is enormous. There's enough room for all those solar power satellites in our orbit, and each of them will be able to generate as much electricity as we get from a power station. If this worked out, we would be able to convert this energy to microwave energy. This type is similar to high-frequency radio waves you can find in a regular microwave oven. Then, we transmit it down to our planet and use it in everyday life. We'd need many antennas all over Earth to do this, of course. They would pick up the beams so that energy could be transformed into electricity in the end. Scientists are going to get millions of dollars to try out these space-based solar power projects, SBSP. These satellites will consist of hundreds of thousands of tiny identical pieces produced in our factories. The cool part is that we will have robots that will put them together. Scientists will program them to work on their own without any help. These robots will also service and maintain satellites when necessary. Of course, using solar energy isn't a new thing. It's an important resource for humankind right now as well. But it's not the same level as having solar panels in space. It's different because our atmosphere diffuses sunlight. In space, we will get this energy directly from the sun. Nothing will interfere with the process. Microwaves can easily go through clouds in our atmosphere. Also, sunlight in space is available at all times, so you can get energy not only during the day. Plus, the light is more intense up there than it is after it goes through all the layers of our atmosphere. Scientists from the UK are currently working on this project, but teams from all over the world want to develop and set up these space-based solar panels everywhere so people across the globe can benefit from them. They're working on this project in the US too. Scientists have already tried out a new thing called a sandwich tile. They used it to transform solar energy into radio waves. Microwave beams do sound like something dangerous when you first think about it. But scientists have tested them and found out that they are efficient and also very safe for wildlife on our planet and us. They tested this principle on a small scale first. They beamed microwaves from one point to another, and the distance between these points was 110 feet. A microwave beam is like a Wi-Fi we have all over the planet. It's not very intense, approximately a quarter of this intensity of the midday sun. This idea is not new. Scientists have been considering it for over 50 years, but it was too expensive and too complicated to implement because we didn't have technologies good enough to do that. But now it seems possible. The study where they'll test it will take 3 years, and the goal is to see if these large solar farms we want to build in space can really work. Another question is if we will be able to get them at a reasonable price too. The sun is an awesome source of clean energy, and we might get even more energy than we can consume now or will consume in the future. To get solar energy from space, we need solar panels. Inflatable mirrors or reflectors will collect sunlight and direct it onto those panels. Then, they will beam solar energy onto Earth. If this works out, solar energy will top all the other sources of energy combined. So, why don't we have solar panels in space already? It's expensive, okay, but there's also a high risk of space debris or radiation damaging these solar panels. Another risk is that we're likely to lose too much energy while transporting it back to Earth. So many new exciting space discoveries have been made over the past few years. For example, a super-Earth we discovered in 2017. It's an exoplanet, which means it orbits a star that's not in our solar system. And a super-Earth is a term we use to describe a planet more massive than Earth, but also lighter than ice giants, such as Uranus and Neptune. A super-Earth can be made of rock, gas, or a mix of both. It can be up to 10 times Earth's mass and twice its size. This cool super-Earth we found several years ago is 21 light-years away from us. It makes a full circle around its parent star, which is an M-dwarf star, in just 2 weeks. So that's how long a year lasts there. I don't even want to think about how old I'd be there. Wouldn't mind more presents, though. There are some planets out there that could harbor life, too. One of them, also discovered in 2017, could be the closest one to us where there's a possibility of life. This year, scientists found another super-Earth. It's 40% bigger than our home planet and closer to its star than we are. But its sun is over 6 times smaller than ours, and its temperature is twice as low. We don't even have to travel far to find new things. There's so much we don't know about our own solar system. We've discovered a new moon orbiting the biggest planet in our solar system, Jupiter. Jupiter is gigantic, which means its gravity is very strong and attracts many space objects. Take a look at our home planet. It has 1 moon. Mars has 2. And there are at least 79 moons orbiting Jupiter. I mean, there are probably hundreds of moons we have yet to discover. The new one circles around Jupiter in the opposite direction of Jupiter's rotation, and it's positioned at an extreme tilt relative to Jupiter's orbital plane. And we have some work to do in our own neighborhood too. NASA will go back to Venus by 2030. The last time scientists launched a mission there was in 1989. The reason why no one continued exploring Venus is probably that people are talking about going to Mars most of the time. Researchers have discovered something called phosphine in Venus's atmosphere. This element is special because on Earth, only the activity of humans and microbes produces it. So there could be some forms of life on Venus. There could have been a world with rivers and oceans on this planet a long time ago, before its surface became hot enough to literally melt lead. You can't talk about discovering new things in space and not mention at least one black hole. This newly found one, called the Unicorn, is only 1,500 light-years away from us in the constellation of Monoceros. That makes it the closest to Earth black hole that we know about, and scientists found it when they noticed the light of its companion star become brighter. They understood that something was tugging on that star, even though they couldn't see the black hole directly.
This catapult-like system on the moon might bring us limitless energy. It's a launch system concept that was recently proposed by the Chinese scientists. It would work like a hammer throw, spinning a launch arm that flings objects. This arm is supposed to be about 165 feet long. It will accelerate until it reaches the moon's escape velocity, and then whoosh, the capsule is sent into space. This crazy idea will cost around $18 billion. Ooh, pricey. But trust me, it's totally going to be worth it. The system would be powered by solar panels and nuclear energy. It could also recover more than 70% of the energy used after each launch. The moon has a very weak gravity, There's also barely any atmosphere, so the air doesn't weigh you down. This makes it so much easier to launch stuff there. But why do we even need this? The main purpose is to transport helium-3. It's a really cool isotope of helium, and one of the most insane things about it is that it could become fuel for nuclear fission. This is the same process that happens in stars, including our Sun. If we manage to recreate nuclear fusion here, on Earth, we can make it a clean and basically limitless source of energy for power plants. But helium-3 is super rare on Earth. We can sometimes find it in volcanic rock formations on the ocean floor. That's because it's a product of another rare element called tritium, the element we usually make in nuclear reactors and put in cool stuff like glow-in-the-dark paint. But the catch of tritium is that it takes forever to decay and turn into helium-3. Now, there's a bunch of helium-3 on the Moon, around 1 million tons. Just 20 tons of helium-3 could meet China's yearly electricity needs. In fact, lunar soil has enough helium-3 to power the entire world for over 1,000 years. But why is there so much of helium-3 on the Moon and barely none on our planet? Well, that's because helium-3 comes from the Sun and travels in solar winds. Solar winds are like streams of dangerous particles. They're super radioactive. Our planet's thick atmosphere and magnetic field serve as a shield for us. They almost fully protect us from those particles. But, unfortunately, they also prevent the good stuff like helium-3 from getting here. The Moon's atmospheric shields are super thin though, so it's under a constant shower of solar winds. So, helium-3 accumulated there over billions of years, and now it's just scattered around there. But mining it and bringing back to Earth is no easy feat. It's super expensive. Just think about it. Rockets need tons of fuel to break free from gravity. Every single bolt and screw on the spacecraft must be engineered to survive extreme conditions, like radiation. Not to mention, you need a team of rocket scientists, literally working around the clock to make sure nothing goes wrong. You can't call a repair guy if something breaks on the Moon. So generally, it costs about $500,000 to send 1 pound of payload to our satellite. That's based on estimates from NASA. To get some idea, let's calculate how much it would cost to send an apple to the Moon. A typical apple weighs about 0.4 pounds, so that funny mission would be at least $200,000. Now, for comparison, the Chinese launch system weighs around 80 tons. Another problem is that the lunar surface is pretty harsh on the equipment, like the freakish lunar dust, for example. You might recall this small thing that happened in the 60s called the moon landings. But when the Apollo astronauts came back from the Moon, they found something weird was happening to them. Their throats were sore and their eyes wandered. Luckily, it wasn't some scary moon sickness. Turns out, there's a lot of lunar dust clinging to their spacesuits. This dust seems harmless, but it's made up of sharp and abrasive particles, much smaller than a human hair, yet sharp like glass. It contains silicate, a thing that can cause severe lung problems on Earth and is a common issue for miners. So it caused a lunar hay fever. At least that's how NASA astronaut Harrison Schmitt called it. All 12 astronauts who walked on the Moon were then sneezing and experiencing nasal congestion. Sometimes it took days to fade away. The dust even got inside their spacecraft, smelling like burnt gunpowder. This nasty stuff can be harmful to both humans and equipment. It managed to damage spacesuit boots and even ruin the seals on the containers used to bring back samples during the Apollo missions. As we mentioned, they're glass-sharp and jagged, so they start scratching, grinding, and wearing down any surfaces they come in contact with. They don't care if it's metal, glass, or humans. And since there's so much dust, this causes equipment to malfunction and fail quite quickly. And that's just one of the possible hurdles with lunar missions. So scientists really need to come up with some weird ideas to get that precious helium-3. The Chinese scientist project looks like a weird sci-fi invention, but it's a cost-effective way to transport materials back to us. It could throw stuff to Earth twice a day, and it would be 90% cheaper than current methods. Since it only needs electricity and no fuel, the system would be small and easy to set up. Besides the beloved helium-3, This catapult would also help advance technologies in space mining and heavy launch vehicles. No lunar dust scares this thing. It should last for at least 20 years. It would need to be transported to the moon using China's super heavy lift rocket. But the idea is far from new. There was a novel called The Moon is a Harsh Mistress by Robert A. Heinlein. In the story, there's a lunar colony that uses an electromagnetic catapult to send weed and water ice back to Earth. It gets quite wild when the colonists, known as loonies, eventually take control of this catapult. They threaten to launch rocks at Earth unless their colony is recognized as an independent world. Sounds kind of funny, but a large rock, if thrown at us from the moon, could wipe out a city. The damage would be like from a meteorite strike, with fires, houses destroyed, and worse. But scientists have been talking about this catapult idea for a while. For decades, they were trying to find a way to use electromagnetic systems to send resources from the moon to Earth. There are also some challenges. For example, scientists forgot to mention how exactly helium-3 would be extracted from the lunar soil. Installing this launch system on the moon's rugged surface would be difficult as well. Also, they would need to make sure that the system remains stable at high speeds and that it could withstand the moon's extreme temperature changes, cosmic rays, and intense solar radiation. So, it would take some time to develop. China hopes to have the key components of the system ready by 2030. The full-scale operations might start by 2045. China has tons of plans for the moon. For example, they want to build a research station at its south pole by 2035. But China's not the only one in this space race. Considering that NASA plans to send humans on Mars by that time, oh boy, the 2030s will be a crazy decade for space exploration. There's also an American startup that's part of the lunar economy. The ones that plan to land astronauts on the moon have people actually living on our satellite in a decade or two. One of the goals of this colony is to boost economic growth and create new jobs. Most of them will likely involve some mining activities. And if there'd be 2 space colonies, well, they'll have to figure something out. That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.